I think John already made, maybe I take a microphone. Required to make it work. No? This one would. Yeah, great. Before I start, I am almost 40 years in the lighting industry, developing products, applications. And then I got into 4UV, and I swear this is the most complicated business I have ever been in. I mean, it's so great to be here at this conference, but when, even for you, when you look at the broad range of presentations that we heard, all related just to 4UVC, and how many new discoveries and open questions are there. And that is only the science, and then, as John already touched on it, there comes the business on top of it. It is a super complicated business. So, in the industry, sometimes when we have a question, we do an analysis. It's called a SWOT analysis: strengths, weakness, opportunities, threats. And I try to do that a little bit. I hope you can read it. And it's only a starting point. We could fill pages of things, but let's review what do we know about 4UVC. And I think what we know and are confident with is we can kill pathogens. There's no doubt about it, and we can kill them safely while people are around. And the doses that we need and the energy that we need to do that are fairly low. Good news is, over the last couple of years, a whole bunch of manufacturers have taken on the task to develop fixtures, better or worse, but they exist, they are available. So they can be used today. There is at least an increasing awareness of this technology, and I think to see that more and more people are aware and see benefits and so on. We certainly have a fairly large research community, but I will say one thing, compared to the indoor air research community, it's nothing. I'm invited to the indoor air conference in 2 weeks in Hawaii. I think they expect somewhere around 2,000 participants or something like that. So, yeah, we are definitely small, and that also applies to the funding resources for the research. But the good news is, especially over the last year, the research funding, at least from what I see or think to see, especially with these philanthropic companies coming in, there's more funding becoming available, also from government funds. So I'm very optimistic. Now let's look at some weaknesses. John already mentioned it. It's the most expensive GUV technology. And we are working on that, but there is limitations how low we can go. It, of course, always depends on the quantities, and that depends on the market. We must not ignore in even discussions with customers. There is side effects that exist. They can be maybe mitigated, but they exist, and we have to be honest and open that they exist. There's some latest observations that there may be irritation of eyes, even at low levels of irradiation. We know for sure that some materials change colors when they are irradiated with 222. It's very clear that plants do not have any resistance or repair mechanisms to 222. You can kill them safely, repeatedly, in a short time. Tried it, but you don't have plants indoors you don't have to have plants indoors if you want to fight infection. There's definitely the issue that the 222 light creates ozone. And of course, we also know that there is VOCs and particles created. On top of that, we have a very intense and complicated sales cycle compared to other technologies. These salespeople have to almost be PhD level to explain all the technology to the customers, and the customers are very inventive, coming back to you with very crazy questions. Valid questions, but still, the salesperson has to have the answers right there and then come back. It's a long sales cycle, and little questions can throw the sales cycle totally off rails, as John already mentioned. And yeah, very frustrating, at least from my side. We still don't have good models. The problem with indoor disinfection, air disinfection, surface disinfection, I always say the room is the reactor. Yeah? In water, you build a reactor, it's all closed and so on, you can verify that and that. In indoor air, yeah, every room is different, the ACH are different, the airflows are different, people are different. How do you model and give a reasonable, prediction what the effect of such an expensive installation is? And yeah, we have to improve on that. You have to improve on that. That we can somewhat predictable tell customers what to expect. And to be honest, yeah, the data that we have for 222, how many pathogens have been measured and so on, we need much more data, reliable data especially. And of course, then the big elephant in the house, does it work in real application? And so far, we have nothing but models and predictions, and some stories. Yeah, no doubt they exist. But we need scientific evidence that with 4UVC we can actually reduce infections. That costs a lot of money, a lot of time, a lot of dedication, and a lot of smart people to be involved. But we have to be aware at the moment. Yeah, we are making predictions about this infection, but there is no evidence. Of course, there is all these opportunities, and I mean, that's why we are here. There is opportunities, there is a need for this technology. When we talk about healthcare acquired infections, I mean, it's a huge problem. Yeah? In the US alone, 100,000 people die from that every year. 1.8 million or so get infected in hospitals. And maybe in Great Britain there is not such a problem, but in the rest of the world there is a problem, yeah? And it's an expensive problem. HAIs in the United States cost about $30 billion a year in extra health cost. So if we only have a 5% impact, yeah, for hospitals and of course for the people, it is a measurable, huge impact in money and in health and life expectancy. So that keeps us optimistic and going. Of course, there's also the opportunities, light source development. John already brought it up. I think we will need a longer lifetime lamps because maintenance of such fixtures can be a big burden. Semiconductor light sources certainly are coming, will be coming, various types. And then there are new applications. My colleague Ryan yesterday gave you a couple of glimpses where early research showed there is many more possibilities. And we also met someone here at the conference that is in agriculture animal, and yeah, there's also very positive vibes that in animal care, food production for UVC can have huge impact. And then of course we have threats. So let's say the UV industry is existing for, let's say, 5 years. Ushio started earlier and provided light sources early on, invested super heavily. But we have to be aware from a size standpoint, from a market penetration standpoint, and so on. The manufacturers are in a startup mode. Yeah? And they promise their investors, hey, there will be a bright future. I don't think anyone in the world has ever made money with UVC. And if that continues, there is no doubt that there will be fallouts. And it could be devastating. The moment we hang in, we do our best, but how long can this industry survive? We hope for long, but it is a threat. Yeah? The public perception and acceptance. Yeah, last year I gave a presentation at ICFAST about ozone generation, and there were a couple of universities also presenting with big messages on how dangerous and so on, and I asked for restraint, don't overdo it, and well, this year some of these people, maybe not these people, yeah, they basically used that message against us and went into full action to outlaw UV. And then, of course, there is regulatory threats. And I also want to mention, when we start gathering evidence, especially in real application, there is a possibility it goes wrong, that we don't see the results that we expect, and that can be a threat. So just a couple ideas, I think needs from the research side. Yeah, everything has already been said, but yeah, we need more safety research. There's a couple questions left. I don't think there will be any earth-shattering surprises, but some of these uncertainties should be investigated further. Has been said many times, reliable susceptibility values for pathogens are needed, and I am essentially sure they are different for air and for surface disinfection, so it's almost two separate categories, but we need more reliable data. And the current data for 222 are spare anyway, but they still vary by probably 2 log when you look at the available data. We need more robust models, especially for air disinfection. We need also better models for surface disinfection, and I also want to mention, many people focused on air disinfection with UVC. We must never forget that the surface disinfection that you can do in occupied spaces, there is no other technology but for UVC to disinfect surfaces while people are around. Yeah, and then of course we need more reliable, more measurements of VOCs and PMs and ozone and so on. And also we need discussions about risk and benefits for UVC. One little observation. Yesterday we heard very good presentations about indoor and SOA and so on. Keep one thing in mind when it comes to conclusion and mortality rates and so on, they always refer to relative risk yeah, an increase in relative risk. When we talk about infections and deaths from infections, we talk about actual risk. Also, both see this, have the word risk, but the calculations and the magnitudes are not directly correlated. So I asked the specialists of risk estimates and calculations to come together and try to do a risk-benefit analysis, combine the views and maybe even the language that is being used for things like that. On the technology side, John already mentioned almost anything that I can come up with. Yes, fixture costs are definitely a problem. More intelligence, connectivity and all that. There's also problems, the testing cost to get a fixture certified and so on. Most of you would not be aware of it, but I think in the United States, you easily talk about $100,000 for a new fixture, just the certification cost. Because you have to register with EPA and then you have to do all the pathogen testing that you guys already did, probably better than any NRTL lab can do. You have to do that again, otherwise you cannot claim that your fixture has the same pathogen reductions. And all that is only surfaces. There is at the moment, in principle, nobody in the world can make a claim about air disinfection efficiency with a 4UVC fixture. Rolf Bergman gave a nice presentation yesterday about the efforts in the United States, certified technicians and so on, to install that. I think that's very important. And yeah, we also have to keep working on standards. Public awareness. We need more and new ideas, and we have to try more things. How can we inform the public that this technology exists, what it can do, but doing that in an honest but simple message that is very, very tricky. I know that from my own experience. And then, maybe a question. When we talk about public awareness, we probably should also think about, what areas are we focusing on? Is it healthcare? Is it next pandemic? I don't know, but it's necessary to think that through. And then, we have regulatory affairs. And the good part is, especially at this conference, we, at least in the United States, I think we have much more attention from important government agencies, CDC, NIOSH, EPA, they're all here. They come to Great Britain and to learn and so on, and I get at least some positive vibes from that. But there could be also unintended effects out of these analyses. And at the moment I have no idea what's going on in other countries. I don't hear a lot. Maybe in Denmark it's a slightly different. European Union, as far as I know, there's nothing going on in regards of support or attention. In my home state, California, probably almost everyone heard by now, a group of concerned people proposed a new bill that will make selling air cleaners with emissions of more than 5 ppb a crime. I'm up to my neck in that. And Gabrielle as well. And it is complicated, and the problem is, if you think you talk about science or arguments, that doesn't work. It is almost religion. Last night we had another call, and They are not willing to compromise, they are not willing to listen. They ignore the 15 or 20 letters by the highest ranking professors in the world and by the entire industry, and they do what they want. Be aware of that, and it may hit us in various other corners of the United States and the world with similar things that can endanger the use and the future of our UVC. And that's it from my side.